Yes, it is permissible to run underground feeder or off cable inside polyvinyl chloride or PVC conduit according to the National Electrical Code or NEC. Specifically, NEC Article 334.10b addresses the installation of UF cable within raceways, which includes PVC conduit. However, a crucial consideration arises when installing UF cable and conduit: the need to derate the ampacity of the conductors. Derating is a reduction in the allowable current carrying capacity of a conductor, and it's necessary because the conduit acts as a thermal barrier, impeding the dissipation of heat generated by the conductors. The specific derating requirements are outlined in Table 310.15b3 of the NEC. This table provides adjustment factors that must be applied to the conductor's ampacity based on the number of current carrying conductors in the conduit and the ambient temperature. Understanding these derating factors is essential to ensure the safe and reliable operation of the electrical system. When UF cable is installed in open air, it can dissipate heat more effectively. However, when enclosed in a conduit, the heat becomes trapped, leading to a temperature rise within the conductors. Excessive heat can damage the insulation of the conductors, potentially leading to short circuits, ground faults, and even fires. Derating the ampacity of the conductors mitigates this risk by reducing the amount of current they are allowed to carry, thereby reducing the amount of heat generated. To determine the appropriate derating factor, you must first identify the number of current carrying conductors in the conduit. This includes all phase conductors, neutral conductors if they carry significant current, and any equipment grounding conductors if they are carrying current. Once you have determined the number of current carrying conductors, you can consult Table 310.15b3 to find the corresponding derating factor. The derating factor is expressed as a percentage, and you must multiply the conductor's original ampacity by this percentage to obtain the derated ampacity. For example, if a conductor has an ampacity of 30 amps and the derating factor is 80%, the derated ampacity would be 24 amps. It is important to note that the derating factors in Table 310.15b3 are based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature exceeds this value, you must apply an additional temperature correction factor as specified in the table. This further reduces the ampacity of the conductors to account for the increased heat. In addition to derating for the number of conductors and ambient temperature, you must also consider the voltage drop in the conductors. Voltage drop is the reduction in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for feeders and 5% for branch circuits. To minimize voltage drop, you can use larger conductors or reduce the length of the circuit. When installing UF cable and PVC conduit, it is also important to ensure that the conduit is properly sized. The NEC specifies the maximum allowable fill percentage for conduits, which is the percentage of the conduit's cross-sectional area that can be occupied by conductors and cables. Exceeding the fill percentage can make it difficult to pull the conductors through the conduit and can also impede heat dissipation. To determine the appropriate conduit size, you must consult Chapter 9, Table 1 of the NEC. This table provides the dimensions and cross-sectional area of various conduit sizes. You must then calculate the total cross-sectional area of the conductors and cables you plan to install in the conduit and ensure that it does not exceed the allowable fill percentage. In addition to these general requirements, there may be other specific requirements that apply to your particular installation. For example, if you are installing UF cable in a wet location, you must choose a conduit that is listed for use in wet locations. You must also ensure that all connections are made in accordance with the NEC and the manufacturer's instructions. Failure to comply with these requirements can result in electrical hazards and code violations. In summary, while it is permissible to run UF cable inside PVC conduit, it is essential to understand and comply with the relevant requirements of the NEC. This includes derating the ampacity of the conductors, ensuring proper conduit sizing, and following all applicable installation guidelines. By adhering to these requirements, you can ensure the safe and reliable operation of your electrical system. The NEC is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date with the latest edition of the NEC to ensure that your electrical work complies with the current requirements. Many resources are available to help you understand and apply the NEC. These include textbooks, training courses, and online forums. You can also consult with a qualified electrical inspector or engineer for assistance. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Always disconnect power before working on electrical circuits, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. They have the knowledge and experience to perform the work safely and in accordance with the NEC. In addition to the NEC, there may be other local codes and regulations that apply to your electrical installation. It is important to check with your local building department to determine the specific requirements in your area. These local codes may be more stringent than the NEC in some cases, and you must comply with all applicable requirements. Electrical safety is paramount, and it is essential to take all necessary steps to ensure that your electrical system is installed and maintained properly. By following the NEC and other applicable codes and regulations, you can protect yourself, your family, and your property from electrical hazards. And always remember, when in doubt, consult with a qualified electrical professional. They can provide expert advice and guidance to ensure that your electrical work is done safely and correctly. Furthermore, understanding the specific applications and limitations of UF cable is crucial. UF cable is designed for direct burial in the earth and is resistant to moisture, sunlight, and chemicals commonly found in soil. However, it is not intended for use in all environments. For example, it should not be used in areas where it is exposed to physical damage, such as in a factory or workshop. In these situations, it is best to use a more robust wiring method, such as rigid metal conduit or electrical metallic tubing. When installing UF cable in conduit, it is important to use the correct type of fittings and connectors. These fittings should be listed for use with UF cable and should provide a watertight seal to prevent moisture from entering the conduit. It is also important to properly support the conduit to prevent it from sagging or becoming damaged. The NEC specifies the maximum spacing between conduit supports, which varies depending on the size and type of conduit. In addition to the derating requirements in Table 310.15b3, there may be other factors that can affect the ampacity of conductors. For example, if the conductors are installed in a poorly ventilated area, the heat can build up, reducing their ampacity. Similarly, if the conductors are exposed to direct sunlight, they can overheat, also reducing their ampacity. To account for these factors, you may need to apply additional derating factors as specified in the NEC. It is always best to err on the side of caution when determining the ampacity of conductors. If you are unsure, it is better to use a larger conductor than is required by the NEC. This will provide a greater margin of safety and ensure that the electrical system can handle the expected load. Remember that the NEC is a minimum standard, and it is always permissible to exceed the requirements of the code. In addition to following the NEC, it is also important to follow the manufacturer's instructions for the installation of UF cable and conduit. The manufacturer's instructions may provide additional information and guidance that is not covered in the NEC. It is also important to use the correct tools and equipment when installing electrical wiring. Using the wrong tools can damage the wiring and create electrical hazards. Always use tools that are specifically designed for electrical work, and make sure that they are in good working condition. Before starting any electrical work, it is important to inspect the wiring and equipment for any signs of damage. If you find any damaged wiring or equipment, it should be replaced immediately. Never attempt to repair damaged wiring or equipment, as this can be dangerous. It is also important to keep the work area clean and free of clutter. This will help to prevent accidents and make it easier to work safely. When you are finished with electrical work, it is important to test the circuit to ensure that it is working properly. This can be done with a multimeter or other testing device. If the circuit is not working properly, it is important to troubleshoot the problem and correct it before energizing the circuit. And always remember, if you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. They have the knowledge and experience to perform the work safely and in accordance with the NEC. Furthermore, consider the environmental factors specific to Florida when installing UF cable. The high humidity and frequent thunderstorms can create challenging conditions for electrical systems. Ensure that all connections are properly sealed to prevent moisture intrusion, and that grounding systems are robust to protect against lightning strikes. The sandy soil in many parts of Florida can also be corrosive, so consider using corrosion-resistant materials for conduits and fittings. Regularly inspect your electrical system for signs of damage or corrosion, and address any issues promptly to prevent more serious problems. Staying informed about best practices for electrical installations in Florida's unique environment will help ensure the safety and longevity of your electrical system. Consider attending workshops or seminars on electrical safety and code compliance specific to Florida's climate and conditions. Local electrical supply houses and trade organizations often offer these types of training opportunities. Staying connected with other electrical professionals in Florida can also provide valuable insights and support. Sharing experiences and best practices can help you stay ahead of potential problems and ensure that your electrical work is always up to code and safe. By taking these extra steps, you can demonstrate your commitment to electrical safety and professionalism.